A manufacturer of speakers makes two models, an economic model that sells for $40 and a professional model that sells for $120. The professional model uses one woofer, two tweeters, and one mid-range speaker. The economy model uses one tweeter, one mid-range speaker, and no woofers. The manufacturer's current inventory currently consists of 20 woofers, 45 tweeters, and 35 mid-range speakers. How many of each model should be manufactured to maximize the income from their sale? If they would be able to sell all these speakers, how much income will this generate? Now we're going to define our variables. In this case, X equals the number of economy models and Y equals the number of professional models. Our first constraint we're going to look at is woofers. Here our constraint is Y is less than or equal to 20. Y, being that the professional model uses one woofer, making it 1Y or Y, has to be less than or equal to the 20, the total inventory of woofers. Our next constraint is our tweeters. Our constraint is 2Y plus X is less than or equal to 45. 2Y showing that the professional models uses 2 tweeters plus 1 tweeter that the economy model uses has to be less than or equal to 45, the total inventory of tweeters. Now we have our mid-range speakers. Our constraint is 1Y plus 1X is less than or equal to 35. This shows that the one mid-range speaker the economy model uses plus the one mid-range speaker the professional model uses is less than or equal to 35, the total inventory of mid-range speakers. Now, because in this problem we know that we can't have any negative variables, we have to set some boundaries for our graphs. So our boundaries are going to be 0 has to be less than or equal to Y, and 0 has to be less than or equal to X. Now it's time to graph our constraints. First thing we have to do is label our axes. Just like we labeled our variables before, we're going to label X as our economy models and Y as our professional models. Now we're going to graph our first constraint, which is Y is less than or equal to 20. This means we just have a slope of 0 at a y-intercept of 20. Before we graph our constraint for our tweeters, we like to make it a little simpler by putting our constraint into slope-intercept form, making it easier to graph. First, we divide both sides by 2, and then subtract 1/2 x from both sides to get y is less than or equal to negative 1/2 x plus 22.5. And now we've added this line to our graph. Before graphing our mid-range constraint, we're going to turn it into slope-intercept form. We're going to do this by subtracting 1x from each side to get y is less than or equal to 1x plus 35. After we've done that, we add the line to our graph. Now it's important to show our constraints. The arrows on our lines indicate which side of the line applies to the solution of our constraints. The shaded areas where all these solutions meet. All of our possible answers will be within the shaded area. Our next step is to identify the corner points of our shaded area. We have 0, 0, 0, 20, and 520. Because 520 is not on an exact point on our graph, we solve the system of equations to prove that x equals 5 and y equals 20. We have 35, 0, and our last point is 25, 10. Once again, 25, 10 is not on an exact point on our graph, so we solved another system of equations to prove that 25, 10 is the point on the graph.
Now we use our objective function to plug in our corner points to find out how many of each model we need to sell to gain maximum profit. Our objective function is p of xy equals 40x plus 120y. First, we plug in our point of 2510 to get p of 2510 equals 40 times 25 plus 120 times 10. We end up getting p of 2510 equals $2,200. Then we plug in our point 520 to get p of 520 equals 40 times 5 plus 120 times 20 to get p of 520 equals $2,600. Now we plug in the point 020 to get P of 020 equals 40 times 0 plus 120 times 20, which gets us $2,400. Next, we plug in the point 350. Our equation is P of 350 equals 40 times 35 plus 120 times 0, which gets us $1,400. Finally, when we plug in 00 to our equation, multiplying any number by 0 is going to give us 0. Therefore, our solution is $0. Out of all 5 of our corner points plugged in, we get the most money from the point 520 with a grand total of $2,600. In conclusion, to gain maximum profit, the company must sell 5 economy models and 20 professional models to earn $2,600. For our alternate solution, we altered our objective function to P of xy equals 100x plus 50y. Now we use our new objective function to plug in our corner points to find how many of each model we need to sell to gain maximum profit. First, we plug in our point of 350 to get P of 350 equals 100 times 35 plus 50 times 0. We end up getting P of 350 equals $3,500. Then we plug in our point 2510 to get P of 2510 equals 100 times 25 plus 50 times 10. We end up getting P of 2510 equals $3,000. Next, we plug in the point 020. Our equation is P of 020 equals 100 times 0 plus 50 times 20, which gets us $1,000. Now we plug in the point 520 to get P of 520 equals 100 times 5 plus 50 times 20, which gets us $1,500. Finally, when we plug in 00 to our equation, multiplying any number by 0 is going to give us 0. Therefore, our solution is $0. Out of all 5 of our corner points that we plugged in to our alternate solution, we get the most money from the point 350 with a grand total of $3,500. In conclusion, to gain maximum profit from the alternate solution, the company must sell 35 economy models and 0 professional models to earn $3,500.